I'm Ansley Yu, and this is my project for Fluid. This is going to be project 1. And let's begin. So you start on to drag a new Fluent here. You want to right click, change this to 2D. You want to go to right click and then new design modeler. Give it a bit. You want to double click the Z to make it perpendicular. Go to sketching. Go to rectangle here. Just hold and click. And then you want to give it dimensions, but before do that you should change the units. I put mine's per millimeters. Then I made my height 1 millimeter. Made my length by length 150 millimeters. Then once you've done that, you want to go to concept, surface from sketches, change it to a box select everything quickly. Select all of that, click apply, and generate. Now you have a surface. And that would be it for the geometry part. So we are moving on to the meshing portion of this. You want to go click on your top wall and name it. Create name section, name it upper wall. Click on the bottom wall, do the same exact thing. Create name section, lower wall. And you want to go into your inlet and outlet. Create name section, inlet, outlet. You want to create name section, outlet, and then you can see it there. Put typo. That really quickly. There we go. And then now we're gonna move on to the meshing. You want to go into sizing. Click the top and the bottom wall. Click apply. Select number of divisions. Click on 1,000. Capture curvature. No. Behavior soft to hard. And generate. Okay, now once that's done, you want to do the exact same thing for the inlet and the outlet. So you go into here, insert sizing, go here, click on that, control click on your outlet, shift click, I think I have to edit that out. Sizing, apply, edge size, element size, number of divisions, this one 20, capture curvature, no, behavior soft to hard, and then generate. Then now for the last step, you want to do face meshing. Click on your face, click apply, keep everything as it is, and then generate. ends the meshing section. If you zoom in, it looks super fine. So now we are moving on to the results section of our lab. Double click on results. You should see this window pop up, and the first thing we want to do is set our lines. This normal location line. Name this the midline. Point 1, set the halfway. So since ours is 150 millimeters, it's going to be 0.05, 0.05, and set the full length, which is 0.001. Set the stems to 100, and click apply. You should see it in the middle there, yep. And do the same, but this time set end line. End line. Set it just before the end of your system and put the full length and pause 100. Apply. You should see it there, and then now you want to make a contour. So go to contour, call it whatever. Location, you want it symmetry 1. Domains, you want variable to be velocity u. Number of contours 110. And click apply. You should see this. Then we can view our chart now. If what you want to do here is click on chart. Okay. Title. Give it an appropriate title. Data series. You can go into here. You can rename this to the midline. Location midline. Make a new one. End line. Location end line. Apply. You should see 2 lines there. Then for x-axis we change this to velocity u, and our y-axis we change that to y. And so you should get a graph that looks like that. It's on top of each other for the most part. Just so happens the flow is fully developed. And I think that concludes it for the Poisson flow. Okay, so now we are moving on to the Couette flow. So I personally have changed nothing about my model or my mesh. So what you can do actually is you can just copy it to here, copy that to there. That's how I get these blue lines up here. And in the interest of time, I'll just run through my assignment because I didn't change much. Rather than making new ones, you have to keep everything the exact same. I am rolling, right? Okay, so once again, nothing changed. Like my fluid is still air. It's got all the exact same values as last time. Boundary conditions. The inlet did change. On default, it's normally it's normally a velocity intervention to a pressure inlet, and make sure the pressure is 0. Right? Yep, 0. Prevent reverse flow. Don't forget that as well. Apply, close. Same thing goes for the outlet, make a pressure and make sure that reverse flow is off. For the wall, you want to keep your lower wall the same, but I'll just open it to show you. Right, like every value is just the same, keep it stationary and keep no slip condition, yep. Tight close. But the upper wall, in Kuwait flow, one of the walls moves, so you want to make this one a moving wall. I put more speed 20 meters per second. No slip, apply and close. And reference values are the exact same as well. Inlet, surface body, yep, same values. And then from there you just want to initialize and run your calculations to have how many iterations you want. For the interest of time, I won't do that. So then we can move on to the results. So this is the results window. Once again, exact same thing as last time. Whereas you have my midline, my end line. Here, midline halfway, full there, yep. Exact same thing. And with my contour being the exact same as well. So let's move on to the chart. So this is my chart, name it something like Kuwait. Data here the exact same. Once again, just put your end and midline, X and Y, velocity U, Y, and that's about it for Kuwait flow. Just a lot of the same stuff. Okay, so now we are moving on to the hybrid flow, and what's strange about that? Once again, I changed nothing for the most part. So just do the exact same thing you did last time. I've already opened my window here. Save time, obviously. I already told you nothing's changed, so my fluid, the exact same air. Flow stays laminar. So boundary. Okay, boundary. They did change. Change your inlet velocity back into a velocity inlet from a pressure outlet or inlet. I mean, I set mine to 20 meters per second, and your wall. One of your walls should be moving. I chose my upper wall. There's no slip, and it's also moving at 20 meters per second. Keep your outlet and lower wall the same. Right? Make sure to prevent reverse flow. Same thing goes for the lower wall. Make sure it's no slip and it's stationary. Right? And then we're going to check the reference values. You have from inlet surface body. And from there, you just want to initialize and run the calculation. And then I've already opened the results window as well. Once again, same exact thing. Right, midline's the same, end line's the same. Sample is 100. My contour is the same. Go to the chart. Right, do the chart again. Right, open chart. Name it something appropriate. Data series, the exact same end and midline. X-axis velocity and Y. Line this, and yeah, that would be about it for the first project.